the march of time. Today, throughout America, are monuments unlike any ever erected in history. They are dedicated not to a ruler or creed, but to the service of the whole American people. They were built by American industry and symbolize the union between business and science, on which is founded the productive power of modern American industrial civilization. But today, U.S. business is again turning to science for help in a new kind of research, the study of the people. For after a decade in which many of its great plants have been idle, the businessman has come to the realization that his knowledge of production has far outstripped his knowledge of the people he is working for, the U.S. public. Since civilization's beginning, the great monuments of the ages have been built on the knowledge of the men of science. Proud was American industry of its mighty machines of production. But to far-seeing manufacturers came early realization that U.S. industrial progress could not be maintained without ever advancing scientific research. So established within their great factories were the laboratories of the industrial scientists. At the General Electric Company was the now famed scientist, Dr. Irving Langmuir. Archetype of the profession he pioneered, Dr. Langmuir applied the knowledge and methods of the pure scientist, pursuing his quiet, unhurried search far from the tumult of workaday business, finding new facts, analyzing them, putting them to use.
I'll ask you to look over my shoulder at the surface of the water so as to see what's going on.
Creating films of oil, one molecule or 1/10,000,000th of an inch thick, Dr. Langmuir discovered vital new clues about the basic structure and behavior of molecules.
You'll see that it expands, pushes back, and suddenly stops when it jams all those molecules up against one another. Now, this part of the surface is covered with these molecules that are erect on the surface and packed in tight against one another.
Dr. Langmuir's experiments opened the way for revolutionary scientific improvements in products and production, which save industry and the U.S. public an estimated $500 million a year. And he became the first U.S. industrial scientist to be awarded the Nobel Prize. Ever broadening are the practical adaptations of the Langmuir principles. Newest is the molecular film, which eliminates reflection from glass. And today, in quiet laboratories throughout the nation, other men are at work, men who are ever pushing forward U.S. industrial frontiers through science. Behind the inferno of mill and smelter, the scientist of metals is continuously blending metallic elements in hundreds of experimental combinations in the everlasting work of improving the basic raw materials of industry. Alloys of chromium and nickel to shave hard steel like butter. To 10 long years of research, still more research to perfect further the process by which fragile tungsten is fused, drawn and spun into tiny filaments for today's electric lights. And further research on powdered metal, molded under tons of pressure, is showing the way to even better methods of machining and alloying. X-ray of the metallurgist, involving an invaluable new adaptation of the Polaroid lens, shows internal strain of metals, gives direct clues to their improvement. Two new metals have a grim significance in today's world. Coming out of the laboratory is an airplane alloy containing beryllium, lighter than aluminum, strong as steel. And just going into production is the most important new alloy of the year, a steel containing silver, which will make battleship armor plate of standard thickness 3 times as strong as the best in today's warships. Popular symbol of 20th century development in chemistry is the plastic. Most versatile of materials, it is transforming the manufacturing processes and the appearance of the millions of humble, common articles every American uses. The number of new plastics is already being exceeded by the new uses being found for them. The spectacular new plastic lucite has properties that are a challenge to the applied scientist. Unlike any substance ever before discovered, clear lucite has the property of transmitting light in one direction while holding the light within itself. It makes possible piping light like water or electricity along a wire, the light turning any corner, staying inside the lucite tube and coming out full strength at the end. Just coming out of the laboratory is synthetic rubber, important wartime necessity. Made of coal, air, and water, the new white rubber is completely free from impurities, tougher and more durable than natural rubber itself. While scientists in engineering make their annual improvements on the U.S. automobile, radio scientists are at work to control it on the road. Direct laboratory attack on the problem is the highway radio, to broadcast localized recorded advice to motorists.
Bad traffic jam ahead. Take Highway 25 to left. Get further instructions from next highway radio. You are approaching intersection with Highway 25.
In the laboratory are other radio control devices designed to make accidents physically impossible. Scientific research is today threatening to make even the most modern hydroelectric plants obsolete. And scientists consider present-day transmission of electric power costly and inefficient. Most important new advances in power transmission are the mercury tube converter and a huge radically designed transformer. Because of these and other new developments, engineers now forecast that within 20 years, high-tension towers will disappear from the U.S. landscape. For power will be far more efficiently transmitted by small conduits underground. And other researchers are working on a machine which challenges even the basic water power principles. When light falls on its chemically balanced cells, electricity is generated directly and immediately. The light from one bulb generates enough to run a small electric motor. So demonstrated in miniature is the vision that someday, by some such simple device, man may be able to generate electric power directly from the light of the sun. In the past year, 280,000 new formulas were pooled by industrial scientists. For they know that one of the basic principles of the scientific method is cooperation among themselves and with the great scientific institutions of the nation. At Harvard Business School, the case for science and the business of distribution is squarely presented by Dean Wallace B. Dunham.
Businessmen shouldn't forget that modern industry is the product of the combined work of business and scientists. Scientists in university and industrial research laboratories have made modern American industry possible with its high wages, low prices, and until recently almost continuous employment. When we leave the material aspects of production, however, the situation is less satisfactory. We do business with and through human beings. We sell to consumers, We don't have an adequate understanding of their wants and their desires and their needs. We need fact-gathering research through the universities and through business organizations, which will study these very important problems. We need the same kind of effective research that we've had from our physical science research laboratories. We need it in laboratories that study the problems of human beings, emotional human beings.
Well known to businessmen are the direct, simple, and large-scale customer research methods of the biggest automobile company. Mailed to 3 million motorists a year, General Motors questionnaires have to be interesting to get replies and friendly to build customer goodwill. And well known, too, is General Motors' Henry Weaver, who has so ably combined customer research with customer relations.
Here is a great new science we're just opening up, getting, organizing, and putting to use the real facts about the habits, needs, tastes, and desires of the people we're working for, namely the American public.
A decade ago at Harvard Business School, a technique of customer research through population sampling was perfected, based on strict scientific controls and the mathematical laws of probability. A true cross-section of the whole U.S. public. The method was simple. A sample of 5,000 personal interviews, a fixed percentage of them from each of 7 geographical divisions. In each division, a fixed percentage was to be distributed among communities of varying sizes. And in each community, the interviews to be apportioned among men and women of 4 income levels: poor, average, better than average, prosperous. Manufacturers tried out the new true cross-section method and found it uncannily accurate in predicting public preference for cereals, soaps, and cigarettes. Realizing the possibilities of an accurate scientific analysis of the state of the public mind, journalists adopted the new technique. Dr. George Gallup began weekly political surveys. Fortune magazine commissioned analyst Elmo Roper to make broader monthly studies of U.S. opinion. Dramatic proof of the accuracy of the new method came in 1936.
Are you sure enough of your system to try it out on the election?
I certainly am.
Challenged by Fortune to prove the accuracy of his system in the presidential election, Roper gives his field staff final instructions.
Ask the questions just as they're written, being very careful that you don't, by word or gesture or inflection, influence an answer either way. Now, if we'll follow these few simple rules, we'll hit it on the nose.
Out to the 7 geographical divisions goes Roper's staff to seek personal interviews with 5,000 men and women, mathematically chosen from every walk of American life, to make up an accurate microcosm of the entire U.S. population. With the presidential election of 1936 still 2 months away, into Roper's office begin pouring the results of the sample survey method's first big public test. When the returns of the full 5,000 interviews had been tabulated and totaled, they indicated a landslide for Roosevelt. Meanwhile, Dr. Gallup had been making a similar test with the same method, and his return showed a similar result. A month later, the accuracy of the new survey was proven, as Franklin Roosevelt was re-elected. His total popular vote within an amazingly small percentage of both of the survey's predictions. Today, the true cross-section survey has become a trusted political barometer, indicating to Congress the public's opinions on neutrality, telling the White House the electorate's stand on a 3rd term. And today, for businessmen whose responsibilities lie in the consumer field, fact-finding techniques have been developed, tested, and made available. For men who have pioneered in these scientific methods have documented their individual experiences for the use of business generally. A new and significant contribution is publication by the Advertising Research Foundation of a revealing analysis of copy testing techniques. The result of 4 years of work by outstanding U.S. research men, its cooperative sponsorship by advertisers and advertising agencies through the Research Foundation, makes it outstanding in method and value. So today stands the challenge to the U.S. businessmen whose concern is the American public. The study of human beings, their habits and desires, their reaction of thought and emotion, will tax the patience, the pocketbooks, and the brains of those who would open this new frontier of American business. In a scientific study, cooperative efforts by all who would benefit has proved the surest and quickest way to success. And success in a science-guided study of the public promises the same rewards that have come with scientific research in the field of physical production. Better business, a better way of living for the American people. Time marches on.